Welcome back to this channel for practice problems for actuarial exams. If you want to find out who I am, go to smarturl.it/Jedi. I use this smarturl.it redirect service so I can remember websites. And if you would like to get my study manual for exam P, go to smarturl.it/BTDT-P. BTDT is an acronym for Been There, Done That, which is how prepared you should be for actuarial exams. When you look at a problem on the test, you should be able to say, been there, done that. If you want to find out about the actuarial program that I direct at Illinois State University, go to smarturl.it/actuary. And if you'd like to make donations for our students, to support our students, go to smarturl.it/help ISU actuary. So here is a problem for today. We have a probability distribution for damages to a car in a crash modeled by this random variable with this probability distribution, which is positive only for x between 0 and 20, and there it's equal to a constant c times x squared minus 60x plus 800. And the particular car is insured with a deductible of 2. This car was involved in a crash with resulting damages in excess of the deductible. Calculate the probability that the damages exceeded 10. So you might not immediately see this, but the statement that this car was involved in a crash with resulting damages in excess of the deductible is trying to tell you that this is what is given. So given that, calculate the probability that damages exceeded 10. So given that the damages exceeded the deductible of 2, what is the probability that they exceed 10? Now we don't know that parameter c, but we know that the function is a density, so the integral of the density has to be equal to 1. So we have to have that this integral from 0 to 20, which is where the density is positive, of c times x squared minus 60x plus 800 dx, that has to be equal to 1. Well, we calculate that integral then. In fact, it has to be that 1 over c is equal to the integral from 0 to 20 of x squared minus 60x plus 800. So what's the integral of that? Well, the function whose derivative is x squared is x cubed over 3. The function whose derivative is 60x is 30x squared. And the function whose derivative is 800 is 800x. And we evaluate this from 0 to 20. At 0, of course, the value is 0. At 20, we get 20 cubed, so 8,000 over 3 minus 20 squared times 30, so that's 12,000, plus 20 times 800, that's 16,000. So 16,000 minus 12,000 is 4,000. 4,000 is the same as 12,000 over 3, so altogether on the right-hand side we have 20,000 over 3. 12,000 plus 8,000 is 20,000. 1 over c is equal to 20,000 over 3, so c is 3 over 20,000. And now we're looking for probability that x is more than 10, given then that x is more than 2. Well, then let's figure out what the formula for the probability that x exceeds a number is, and that's the probability that x is more than d. Assuming that d is a positive number, because it has to be for this probability distribution to make any sense, of course, if d is more than 20, then that probability is equal to 0, because the largest possible value is 20 in this probability distribution. So we also assume, not written out, but that's the assumption that the d has to be less than 20. And then this probability is equal to the integral from d to 20 of the density. Okay, the density is 3 over 20,000 times x squared minus 60x plus 800. So we integrate this function. Again, it's x cubed over 3 minus 30x squared plus 800x. We evaluate it from d to 20, and then we plug it all in, worked out a little bit, and we end up with Well, this peculiar thing that we have 3 over 20,000 in front, and then in the inside we have 20,000 over 3 minus the part that relates to what you get when you plug in d. And the first 20,000 over 3 times 3 over 20,000 is 1. So this whole thing ends up being 1 minus 3 over 20,000 times d cubed over 3 minus 30d squared plus 800d. And then to get the property that x is more than 10, given that x is more than 2, we just use this formula. Of course, that probability is equal to probability that x is more than 10 divided by probability that x is more than 2, because the intersection of the two is just the probability that x is more than 10, because if x is more than 10, then it's definitely more than 2. And then to get these two probabilities, we just plug in, for the d that we had before, we first plug in 10 in the numerator and 2 in the denominator. Okay, we calculate those numbers. And we end up with a ratio of 1 minus 16 over 20 divided by 1 minus 2,224 over 10,000, or 0.2 over 0.7776, and that's approximately 2572, and that's answer D. Please remember this is copyrighted material, and that problems from Society of Actuaries belong to them. I only give you my solution, but a problem as published by Society of Actuaries belongs to them and reproduced here with permission. Good luck in your tests. Good luck in your studies. All the best.